All right, Algebra 2 students. For the rest of the school year, we're just going to be reviewing. We're going to review everything that we've learned since August up until now, and we're going to be closing out the year with a final on all this stuff, so I would highly encourage you guys to keep a nice, neat record of everything that you have. If you want to take notes on these as you go, that might be wise too. It's up to you. I'm going to do a worksheet myself with you guys, and each of these problems is meant to kind of help you guys do your worksheets as you go, just like I have been doing. But ultimately, you can write down the ones I give you for notes, and then you can do your homework just for the homework credit. That would probably be the best way of going about this and keeping the notes with you. If you want, I can even post the teacher examples online so you guys can just print them out if you have a printer, and you can just copy the notes down directly onto the worksheet and keep a record of these notes for your final that'll be coming. That would probably be the best way to study. So I'll say that again. The best thing you can do is I'm going to post these teacher examples as well as your worksheet. The worksheet is just for your homework, practice purposes, but the teacher examples, I would encourage you guys to print those out if you can, and then take notes directly on this worksheet as you watch the video, and keep a record of all these for the next 5 or 6 weeks as we review everything since August. Keep it as a record to help you do well on your final. Okay. So what are we going to start with reviewing? We're going to start talking about linear functions first of all. We're going to talk about how to graph them. That's the first 6 problems. We're going to learn about how to write linear equations from data. So instead of turning an equation into a picture, we're going to take some elements of a function and turn it into an equation. And then we'll also just talk about solving some basic linear equations. Then we're going to move into systems of equations. We'll talk about solving them by graphing. We'll talk about solving them with substitution and elimination. And then we'll close out this particular review session by talking about functions and operations on functions, plugging numbers in, adding functions together, dividing them, finding inverses, etc. So there's 30 problems altogether here as I go through these teacher examples. All right. You don't have to watch all of them, just skip through the video and watch the ones that you feel you need help with. Let's go ahead and begin. So when you're trying to graph a line in the form of y equals mx plus b, the b tells you where to start on the y-axis. This number is your slope, and it tells you your rise and run. Okay, so for this part over here, number 1, I'm going to be starting at -4 on the y-axis. Then my rise and run is 1 and 5, so I'm going to go up 1, run 5. So from this dot, I go up 1 and over 5. From the 4, I go up 1 over 5. And after that, you just connect your dots, and you're good to go. Okay. Now for number 2, you'll notice that we're missing some things. We don't have 2 numbers for our slope, but we can make that solution easy to solve by just putting it over 1. So now I see that my rise is 3 and my run is 1, but we're still missing the b. When that one's missing, it's a 0. So if you're ever missing a rise or a run or both, those are 1s. But if you're missing your b, that's a 0. The reason for that is because adding 0 is like adding nothing, right? So 3x plus 0 is the same thing as just 3x. Or multiplying by 1 is the same thing as not multiplying anything at all, right? So that's why it's the difference between multiplication and addition, which is the reason why you do 1 versus 0. Anyway, I'm going to start at 0 on the y-axis. I'm going to go up 3 over 1 from that point. Connect the dots. Continue here. Number 3. So on number 3, we're missing the slope, so that means it's 1 over 1. But notice there's a negative in the front. That matters. I'm going to start, first of all, at my y-intercept of -1. Now, since my slope is -1 over 1, that means I'm going to go down 1 when I go to the right. Instead of going up 1 and over to the right, we're going to go down 1 and over to the right. So that's going to look like this. And connecting your dots, we have that. Every one of these examples is to illustrate something different. Number 1 was the basic idea. Number 2 is how to deal with missing numbers. Number 3 is how to deal with negative slopes. Number 4 is another situation to be aware of. Notice it's not in slope-intercept form. This y equals mx plus b is what we call slope-intercept form, but this one is not. Now, the way that you get something into slope-intercept form is by getting the y variable by itself. So I'll show you how to do that. So the first thing you're going to do is you're going to move the x term to the other side. Now, since that x and that 9x and that negative 20 are not like terms, we can't actually combine them. So all I'm going to do is I'm going to put them next to each other, like that. The next thing I'm going to do is I'm going to divide both sides by the negative 4. So we're going to divide out the number that is in front of the y. So in this case, 9 and 4 can't really be simplified, but their negatives do cancel out. So we're left with 9 over 4x. And then negative 20 divided by negative 4 is positive 5. And now we'll just graph it the same way we graphed the last 3. So that's kind of the new part to this problem. Knowing how to get that y by itself so it's in the right form to graph. So we would start at 5, and we would go up 9 and over 4. Now, this one's kind of a pain in the butt, because it says to go up 9 and over 4, but the problem is that I can't go up 9 because my graph runs out. Now, you have two options. Option 1 is just to kind of make your own spaces if you want to. So up 9 would be 1, 2, 3, 4, 5, 6, 7, 8, 9. So it'd probably be somewhere up there. And then over 4, so that would be, we can go over 4. That's easy to do. So you could do that, right? Another way to do it, instead of going up 9 over 4, you could do the exact opposite. You can go down 9 and left 4. It would give you the same outcome. So down 9 would be 1, 2, 3, 4, 5, 6, 7, 8, 9, and then left 4 puts me here. So either way, though, you get the line that you need. All right. Next one, y equals 4. Now, the next two problems are unique. These are special problems. Anytime you have a y equals a number, those are just generally going to be a horizontal line. And when you have x equals a number, those are vertical lines. So what you're going to do is you're going to find where does y equal 4. If y equals 4 right here, and you're just going to draw a horizontal line through that. That's how you graph the line y equals 4. Whereas the line x equals negative 2, you're going to find where x equals negative 2, which is right there on the x-axis, and then you're going to draw a vertical line. I didn't draw it very well. Still didn't draw it very well. Let's try again. There we go, a little better. A vertical line, negative 2. Okay, so that's how you graph the ones that have only one variable. All right. Continuing on, I think I'm going to change screens for the rest of these. Okay. Write the slope-intercept form of the equation of the line through the given point with the given slope. So I'm giving you a point and a slope. Okay. So slope-intercept form looks like this. And to have a complete equation, we need to know what m is, and we need to know what e is. All right. So the first thing that we need to do is we need to make sure you guys know what m is. M is the slope, so they tell us that. That's kind of convenient. M is negative 1. The next thing we need to do is we need to find b. Now b we don't know. So b we're going to have to solve for. So we're going to take this little formula and we're going to plug in everything we know and solve for b. The 3 is an x, the negative 4 is a y, and the slope is a negative 1. So I'm going to plug those numbers in for each one of those letters. And now I can solve for B. Turns out that B is also -1. The last step is to go ahead and write your equation. The way you do that is you just take this expression and you plug in the two numbers that you wanted. So we have y equals -1x minus 1. Now it would probably just be written like this, because usually if x has a 1 in the front, we don't write it. Okay, so that's how we find the equation of a line with a slope and a point. Let's take a look at another version of this question. Sometimes they'll ask you to do the same thing, but they'll just give you 2 points. When that happens, you have a little bit more work to do to find your slope. In this case, we don't know what our slope is. So instead, we're going to use the slope formula. y2 minus y1 over x2 minus x1. Each of these pairs is an xy pair. We'll call the first pair the 1, the second pair the 2's. It doesn't matter which pair you call the 1's and which pair you call the 2's. But from here, we're going to go ahead and start plugging some numbers in. So based on how I labeled them up at the top, I'm going to start with y2. y2, I labeled that as the -2, minus y1, which is a -4. Notice I've got double negatives there. The middle one is a minus that comes from the formula. The next one from the number -4. On the bottom, we have x2 minus x1, so that would be 0 minus 5. Simplifying this up a little bit, like we said, the double negatives becomes positive. And then we go ahead and simplify the numerator. -2 plus 4 is 2. 0 take away 5 is -5. So there's my slope, -2/5. And usually when you have a fraction that's negative, we don't really put the negative on the top or on the bottom. We just kind of put it in front of the whole fraction. All right, that's M. Then once again, we got to go and find the B. We're going to do that. From here on out, the problem is pretty much the same as it was last time. We're just going to plug in the M, the X, and solve for the B. So now, I guess there is a little bit of a difference, though. The difference is that we have 2 points to choose from. So it doesn't matter which one you use. I'm just going to use this one. Okay, so I'm going to plug in -4 for y. I'm going to plug in -2/5 for the m. I'm going to plug in 5 for the x. And we want to solve for b. All right, now another difference about this particular problem is the fact that we have a fraction involved and nobody likes fractions. So let's talk about how to deal with that. First of all, I need to multiply these two numbers together. So I want to think of this as a fraction also. And what we do is we just do top times top and bottom times bottom. And what that's going to give me is -10/5. Now sometimes you get lucky enough to be able to reduce this. And in this case, it reduces. But if this fraction doesn't reduce, what you would do is multiply every term by the bottom number to cancel it out. Okay? But in this case, we actually get a little bit lucky. This reduces nicely, and we just end up with -2. So from here, to solve for b, I just need to add 2 to both sides. And we end up with -2 equals b. And so to write our equation, WE for right equation, we're going to write y equals m, which we got -2/5 for, x plus b, it's a -2, so I'm just going to put -2. So the problem is a lot like the last one. You still do the same steps of finding your m and b and then writing an equation. It's just that finding your m is a little bit trickier because you have to find it this time. It's not just given. Also on this problem, you have to deal with fractions a little bit. So let's take a look at another question. So on this one here, you can approach it the same way we did the last problem. It's just that you have to pick your own points to work with because they didn't give us any points. So what you want to do is just pick some points that are there. Like I know this point and I know this point. Those 2 points have the coordinates of 4, 2 and 0, -1. So once you pick 2 points on the line, you can go through the same exact steps we did on the last problem. We can call this pair xy 1s, and we can call this the x2, y2 pair. So now if I wanted to find my slope, we would just do y2 minus y1 over x2 minus x1, which is -3 over -4. The negatives cancel, and we have a slope of 3/4. So that's how you can do it. Or you can get kind of creative here and just realize it's over 4 up 3. The only problem with doing it that way is you have to be careful with your signs. Right is positive, up is positive. You have to remember that left and down are negative numbers, so you have to be careful with your signs if you're going to do it geometrically. But the formula works as well. Now, the next thing we have to do is we have to find our b. Now, to find your b, you're just going to take pick a point, plug in your y value, your slope, and your x value from the point that you picked, and solve. So this is going to be 12 over 4, which is 3, and then subtract. I get b equals -1. But once again, you can tell that just by looking at your picture. It's right there. The b is the y-intercept, so it's -1. So if you have a graph, just go ahead and use the picture if you know how to. It's a lot faster. Finally, we're able to write our equation, which is 3/4 x minus 1. And there you have it. That's how you find the equation of a line. 3 different ways. Now we'll talk about solving equations. I came up with a little acronym, and I've always taught it this way. It's don't call me stupid. But what it really stands for is distribute, combine your like terms, move the smaller x, and then from there you end up with a 2-step equation, which most of you guys just know how to solve at that point. So the first thing you want to do is distribute if you can. Now in this problem that we're looking at here, there is no distribution, so we're good. The next thing we're going to do is combine like terms. So on the left side of my equation, I have 2 like terms that I can put together, the 3x and the 7x. 3x take away 7x is -4x. And then we'll bring down the -3, the equals, and the -7. Next it says move the smaller x. Now that step only applies if you have an x on both sides of the equation, which we don't. So I'm not going to worry about this step. And the last thing to do is just solve it. So from here, most of you guys know how to solve a 2-step equation fairly well. The answer is x equals 1. Okay, let's try another one. All right. Next one. So step 1 is to distribute. I do have some distribution here. So if I distribute the 4 inside to both terms, I end up with 12 plus 20r. Next step is to combine like terms. On the left side of my equation, I have 2 like terms that I can combine. Next one says move the smaller x. Now in this case, I don't have a variable on both sides, so we're going to skip that step. And from there, we just solve. And there you have it. Let's go ahead and move on to another one. Okay. So for this problem, we have distribution. We do right here. I can distribute that 5 in. Now let's see if we have any like terms. Now on the left side, there's no like terms, and there's no like terms on the right side. Now some of you guys might think, well, wait a minute, aren't these p's like terms? Well, they are, but they're on opposite sides. And so for this step, when I say combine like terms, I mean combine any terms that are the same on the left side, and then combine any terms that are the same on the right side, but don't mix the sides together yet. We'll get to that. Next thing we're going to do is we're going to move the smaller x. In this case, we could say p, because we're not solving for x, we're solving for p. So in this case, we do have a smaller p. Which number is smaller, negative 15 or positive 4? Well, negative numbers are smaller than positive, so I'm going to move the negative 15. The way I'm going to do that is I'm going to do the opposite. So this is minus 15. I'm going to add 15, so it cancels over here. And whatever I do to one side, I have to do to the other. So I'm going to put it over here. And that ends up making 19p. And from there, we should be ready just to solve it like we would normally solve it. Add 32 on both sides. And I'm feeling like it's probably going to be p equals 3. Right. Now we're going to move on to a whole new topic. We're going to talk about solving systems of equations by graphing. The way you do this is by graphing each line and finding out where the lines cross. Okay, so let me color code these a little bit. I'm going to graph this one first in blue. I'm going to start off at 3. I'm going to go down 5, right 3. Now for the other one, I'm going to go ahead and do that one in green. Starting at negative 1, I'm going to go down 1, right 3. And the way that you solve a system of equations is basically you're looking for the x and the y that works for both equations. Now, any point that is on the line works for the equation. So, in this case, the point that is on both lines is the point where they cross at. And so that is the solution. The solution would be 3, 2. On this one, the solution would be the point, once again, where the lines are crossing, which is right here. And the coordinates for that one are negative 6, positive 6. This is a no solution situation. If the lines don't cross, there is no solution to the system of equations. Now that's solving by graphing, but usually to solve systems we end up using either substitution or elimination. This one's telling us to use substitution. So a little while back I gave you guys some steps to solve this. First thing is you want to underline. You don't have to do these first few steps, but I find they're helpful for teaching at least. Underline the lonely letter is what I call it. the letter that's all by itself. It's the one that says y equals or x equals. So where is it at? Right here. Y equals. So there's my lonely letter. Sometimes you'll have two of them, and in that case, just pick one and underline it. The next thing you're going to do is you're going to circle what it equals. Circle what it equals. So my lonely letter equals negative 2x minus 21. Step 3 is you're going to plug what was circled into the other equation. Okay, so now since y equals negative 2x minus 21, I'm going to plug that in for the y in the other equation. I'm allowed to do that because that's what y equals. So I can replace y with whatever y equals. Just like that. From there, you're going to solve. So we start with distribution. Multiplying the 5 inside gives us the negative 10x minus 105. Next, I'm going to combine like terms. And from there, two-step equation. Let's see. I'm thinking that would be 96. And then if we divide both sides by negative 12, I believe we're going to end up with negative 8. Now it says just find the x-coordinate, so just technically we could stop there. But a lot of times you do want to go back and find the y value. So what you're going to do is you're going to plug and solve to find the other variable. So I'm going to take this answer here and plug it into one of the original equations. Now it doesn't matter which one you use because both of them should give you the same answer. That's the point of equations. However, I would advise using the one that has a lonely letter because it's usually easier to use that one. So I'm going to replace x with what I got for x. I got negative 8. So the two negatives there, negative 2 times negative 8 makes 16. And 16 minus 21 is negative 5. So there's the y value and the x value. Those two lines would cross at the point negative 8, negative 5. Okay, and that's how you solve a system of equations by itself.